Chemistry Week 3. Today we're going to talk about molecules and compounds. We've already talked about a few molecules and we're just going to learn more about what a molecule and a compound is. So a simple example of a molecule would be two atoms of oxygen. Two atoms of oxygen make an O2 molecule. And this is an example of a pure substance or an element. We can also have three atoms of oxygen that come together to form O3. And O3 is known as ozone. And this is still a pure substance and an example of a molecule. If you note in this particular slide, they've shown the molecule two different ways. And in this molecule here, they're showing that this particular molecule has two different kinds of bonds. And we will learn more about that in a moment. So we know that two or more atoms of one element can come together to form a molecule. But atoms of different elements can also come together to form a compound. In this example, we have two hydrogen atoms and one oxygen atom coming together to form an H2O or a water molecule, which obviously we've already talked about. So both these types of examples that I've shown you of molecules, they're both molecules. So we can have a pure substance that is made up of more than one atom of one element, or we can have atoms of two different elements coming together to form a molecule, and that's known as a compound. Molecules are made up of atoms, and each kind of matter has its own molecule. An oxygen atom has two electrons in position to hold on to another atom, and they can form a bond this way. So if you look at this example of an oxygen atom, and you've seen this last week in doing your homework and filling out the different sheets, worksheets that were given, and in learning more about the Bohr-Rutherford model of an atom, that we have the shells and with the electrons, and with the oxygen, you have a single electron here and a single electron here, and both those electrons are available to get together with another atom. So H2O and O2 are examples of small molecules, but there are molecules that can be quite large as well. So here we have a larger molecule, and this would be quite a large molecule, but there are molecules that are even bigger than this. And this is an example of glucose. Glucose is a type of sugar. It's a pretty large molecule. You know, in the last couple weeks, you've learned a lot about chemistry. And if you look at this molecule, you'll see that it's made up of three different types of atoms. You have the carbon atoms that are black, you have the oxygen atoms that are in red, and you have the hydrogen atoms that are clear or white. So from what you've learned so far, what kinds of branch, or which branch of chemistry would this molecule belong to? Now remember, compounds are molecules made up of more than one element. So here we have a compound. Glucose is actually made up of three different kinds of elements. Now I said we could have even bigger molecules than glucose. In fact, our bodies are made up of very complex molecules called macromolecules. And if you look over here, DNA and RNA, which is, it's basically the blueprint for who we are as a biological organism. DNA and RNA are both examples of macromolecules. So our body, our biology is full of very, very complex molecules. It's really amazing. Molecules and compounds become these because they share electrons. So how are molecules and compounds made? And what is the difference between a compound and just a molecule? A compound is different from just a molecule of O2 or H2 or N2 because when two different elements come together, they chemically bond together, forming a new substance. And actually, O3, ozone, is a different substance than just O2. So in this chemical bond that's made, a connection forms between the elements and atoms that keeps them together under normal circumstances. And this gives them greater stability. One thing you'll learn as you study more chemistry is that atoms and substances, they really, really want to be very stable. And so they want to get to the most stable form that they can. There are millions of different compounds. And of course, one of the examples, which we've already talked about many times, is sodium chloride. Sodium chloride is table salt. And it is the combining of the elements sodium and chlorine. And they are held together by a chemical bond. So if you've already begun to put together your periodic table, or you worked on the worksheets last week, you'll already have seen that both sodium and chlorine are elements on the periodic table. And when they come together, they form sodium chloride, which we all know as table salt. Okay, so now let's talk about something called a mixture. When two or more pure compounds like salt and sand are physically combined or mixed together, they form what's called a mixture. So here we have a beaker full of what we all know is Lego, okay? So I just threw a bunch of pieces in this beaker, and this is an example of a mixture. We have all kinds of different pieces in here. We have the bigger ones and the smaller ones and all different colors. And so a mixture is just a bunch of different substances that are thrown together physically and mixed together. The difference between a mixture and a compound, again, is that a compound is chemically bonded, like two pieces of Lego that are bonded together. That's the difference between a mixture that is just a physical combination and a compound, which is a new substance that is chemically created by a bond. So sand is a pure compound called silicon dioxide. And I'm just going to show you another example of a mixture. So if we take water and we add some sodium chloride, which is table salt. Add a little bit more there. mix it together. The sodium chloride, the table salt, should nicely dissolve in the water. It's just about gone. Okay, then we're gonna take some sand. We add that to the water as well, and we mix it together. And you know that the sand is not going to dissolve in the water like the salt will. Now, mixtures can usually be separated in some way. There's different ways that can happen. Most of them, anyways, there's ways to separate them. So what I'm going to do is I'm going to pour this mixture now that I've made into another beaker. All right, there it goes. Pretty much all of it. Great. And we're just going to leave that for a second. And it's gonna run, the water's gonna run through the coffee filter into the rest of the beaker. Okay, so we're gonna wait on this and see what happens and what it looks like in the end. And we're just gonna talk about the different kinds of mixtures that we can have. There's two different kinds of mixtures. Here we have a slide that shows different kinds of mixtures we can have. Okay, so we can have a homogeneous mixture shown over here, and that's the type of mixture you would get when you pour the salt into the water, stir it around, and wait for it to dissolve. It means that the particles are distributed uniformly. So something like vodka, an alcoholic drink, or steel, or air, or rain. These would be homogeneous examples of homogeneous mixtures. And then we have the heterogeneous mixture. And this is a type of mixture where the particles are not distributed evenly. So let's just say cereal and milk, or ice in a fountain drink, or in some kind of beverage. Or soil. We talked about soil in our ecology unit and how soil is a mixture of many different things. Or blood, actually. Blood is a heterogeneous mixture because there are different things in our blood and it's not always uniform. So if you look at this slide, it says blood is a heterogeneous mixture. It is a fluid that circulates throughout our body. It carries nutrients. So nutrients is one of the things that is in our blood that is brought to all the different parts of our body to feed our body and the different cells. It carries oxygen. So when we breathe, we take up oxygen, and the oxygen is put into all of our into our blood vessels, and it's moved throughout our body, and that oxygen is distributed. And it also removes the waste that is produced by the different cells in our bodies and by cell metabolism, and it has to be removed. So example, carbon dioxide is one of the wastes that's removed. And then we have all the different types of blood cells, and the blood cells are moving to different places. If you have a cut on your hand or something, your body's going to send white blood cells, or it's going to send different things to fix that area of your body, or if you have inflammation somewhere or something. And so our blood is an example of a heterogeneous mixture that's in us. So there are lots of different kinds of mixtures. There's liquid mixtures, liquid mixed with liquid. There's solid mixed with solid. There's gas mixed with gas, liquid mixed with gas, liquid mixed with solids. There's just all different kinds of combinations that make up different mixtures. All right, so we're just gonna have a look at this mixture right here. And what you can see is when I poured out the mixture, the sand has been left behind in the coffee filter. So this is a mechanical way of separating this mixture. However, we know that the salt dissolved into the water, and so we have to separate the salt from the water in a different way. And so one of your homework assignments this week is actually to do this demonstration that I just did. And then we're just gonna sit and wait and see what happens. If we just leave this sitting here now till next week, we'll actually see that the water has evaporated and what's left behind is the salt. So you're gonna try that at home this week, and you're gonna wait and observe how that all happens. Thanks.